Download this code from codegive.com, link in the description below. Building libraries with Xcode 7.2, potential pitfalls and workarounds. Xcode 7.2, while functional, is a relatively old IDE. Building libraries, specifically static libraries or frameworks, with it can expose you to certain bugs and compatibility issues, particularly when those libraries are intended for use with newer versions of Xcode or later iOS/macOS SDKs. This tutorial will highlight potential pitfalls and provide practical examples to help you navigate them. Introduction to building libraries in Xcode. Before diving into the problems, let's establish a clear understanding of building libraries in Xcode. There are two primary types. Static libraries, data files. These are archives of compiled object code. When you link against a static library, the linker copies the object code into your application executable at build time. This results in a larger application size but no external dependency at runtime. Frameworks. Framework directories. Frameworks are bundles that contain resources like headers, compiled object code, images, and localization strings. They can be dynamically linked, copied into your application package, shared at runtime if they're system frameworks, or statically linked, embedded into your application like a static library. Frameworks are generally preferred as they allow for better organization, versioning, and code reusability. 2. Xcode 7.2, a look back and its limitations. Xcode 7.2 was released in late 2015, targeting iOS 9 and macOS 10.11, El Capitan. Its significant limitations stem from its age. Older Swift compiler. Xcode 7.2 uses an older version of the Swift compiler, Swift 2.1 or 2.2. Libraries built with this compiler will not be compatible with projects built with Swift 3.0 or later. Limited SDK support. It lacks the SDKs for newer iOS and macOS versions. This means you can't directly target features introduced in later operating systems. Lack of bitcode support. Potentially, while Xcode 7 can support bitcode, its implementation is early. Bitcode is an intermediate representation of your code that Apple can recompile for specific device architectures during app submission. Issues arise if the bitcode support is buggy or incomplete, leading to archive submission failures. Architectural issues. Xcode 7.2 might not fully support newer ARM architectures found in modern iOS devices, or the latest macOS architectures, example Apple Silicon. Deprecation of features. Certain features and APIs that were common in 2015 have since been deprecated or removed, potentially causing compatibility problems. Build system issues. The older build system might be less robust than modern Xcode versions, occasionally resulting in unexpected build errors or linker issues. 3. Potential bugs and issues when building libraries with Xcode 7.2. Here's a breakdown of the bugs and issues you might encounter. 1. Swift version incompatibility. Problem. If your library is written in Swift, the most common and critical issue is Swift version incompatibility. Libraries built with Xcode 7.2 using Swift 2.x will not link cleanly into projects that use Swift 3.x, 4.x, or 5.x. You'll encounter compiler errors related to type mismatches, missing functions, and syntax differences. Code example, Swift. Solution. Avoid Swift. If possible, build your library in Objective-C. Objective-C has better backward compatibility. Use Swift 2.3 conversion. Xcode 8 offered a migration tool to convert Swift 2.2/2.3 code to Swift 3.0. This is the only officially supported upgrade path. You would need to build your library with Xcode 8 after migrating, not Xcode 7.2. Rewrite the library. The most reliable approach is to completely rewrite the library using a modern version of Swift and Xcode. This guarantees compatibility with the latest SDKs and avoids potential issues from migration tools. Objective-C bridging header. If you are using Objective-C and Swift together, ensure you have set up the bridging header correctly to expose Objective-C code to your Swift project, and vice versa. 2 ABI, Application Binary Interface, Issues Problem. The Swift ABI has undergone significant changes over time. Attempting to link a library built with an older Swift ABI, as found in Xcode 7.2, with a newer Swift runtime will cause crashes at runtime or undefined behavior. Solution. Similar to the Swift version incompatibility, rebuilding the library with a modern Xcode version is the only truly safe way to ensure ABI compatibility. Objective-C doesn't suffer from this as dramatically. 3 Bitcode related problems. Problem. If you enable bitcode in Xcode 7.2, you might encounter issues during app submission to the App Store. The bitcode generation and optimization in Xcode 7.2 were less mature than in later versions. This can result in App Store validation errors or even runtime crashes if the generated bitcode is faulty. Solution. Disable bitcode. If possible, the simplest workaround is to disable bitcode in your library's build settings, and in the project that uses the library. This prevents the need for Apple to recompile your code, bypassing potential bitcode-related problems. Note that Apple requires bitcode for watchOS and tvOS apps, so disabling bitcode is only an option for iOS and macOS targets. Upgrade Xcode. Building the library with a more recent Xcode version with a stable bitcode implementation is the preferred solution. For architectural compatibility, ARM7 vs ARM64, etc. Problem. Xcode 7.2 might not fully support all ARM architectures found in the newest iPhones and iPads. If you are targeting devices that were released after Xcode 7.2, your library might not run correctly, or at all, on those devices. Similarly, it may have compatibility issues with Apple Silicon Macs if compiled specifically for Intel. Solution. Check valid_archs and archs build settings. Ensure that the build settings for your library target include all the necessary architectures, ARM7, ARM64, i386, x86_64. However, note that simply adding architectures to Xcode 7.2 might not completely resolve the issue if the underlying tool chain lacks proper support. Rebuild with a newer Xcode. The best solution is to rebuild your library with a newer Xcode version. Newer Xcode versions automatically handle architectural compatibility and generate universal binaries that can run on a wide range of devices. 5 SDK and API availability. Problem. If your library utilizes APIs or frameworks that were introduced after iOS 9 or macOS 10.11, your library will either fail to compile in Xcode 7.2, or it will crash at runtime on older devices that don't support those APIs. Solution. Conditional compilation. Use available checks in your code to conditionally execute code based on the OS version. This allows you to provide fallback mechanisms for older devices. Weak linking. Use weak linking to link against frameworks that might not be available on older devices. This allows your application to run on older systems without crashing if the framework is missing. You check if the link symbol is available at runtime before using it. Avoid newer APIs. If backward compatibility is crucial, avoid using APIs and frameworks that were introduced after the target OS version of Xcode 7.2. 6. Build system quirks. Problem. The build system in Xcode 7.2 is older and can sometimes exhibit unexpected behavior, particularly when dealing with complex build configurations or external dependencies. You might encounter random build failures, linking errors, or code signing issues. Solution. Clean and rebuild. Try cleaning your build folder, product-clean build folder, and then rebuilding. Check build settings carefully. Double check all your build settings, paying close attention to the header search paths, library search paths, and other linker flags. Make sure these settings are configured correctly. Simplify your build. If possible, simplify your build configuration by removing unnecessary dependencies or build phases. Upgrade Xcode. Again, the most reliable solution is to migrate to a newer Xcode version with a more robust and predictable build system. 7. Code signing issues. Problem. Code signing in Xcode 7.2 can be finicky, especially when dealing with different provisioning profiles and certificates. You might encounter code signing errors during the build process or when attempting to submit your app to the App Store. Solution. Review code signing settings. Carefully review your code signing settings in Xcode. Ensure that you have selected the correct team, provisioning profile, and certificate. Clean up provisioning profiles. Sometimes, outdated or conflicting provisioning profiles can cause code signing issues. Remove any unnecessary provisioning profiles from the Xcode preferences. Keychain access. Make sure that your signing certificates are properly installed in your keychain access application. Create new provisioning profiles and certificates. If you're still having trouble, try creating new provisioning profiles and certificates. This can sometimes resolve code signing problems caused by corrupted or misconfigured credentials. Let Xcode manage signing. Limited Xcode can attempt to automatically manage code signing, but in older versions, this may be less reliable. Upgrade Xcode. Newer Xcode versions have significantly improved code signing capabilities and are generally more reliable. 4. Objective-C versus Swift considerations. Objective-C generally more backward compatible. You can compile Objective-C code with Xcode 7.2 and use it in projects built with newer Xcode versions, provided you avoid using APIs that are unavailable on older SDKs and properly handle API differences. However, it may need some adaptation to modern Objective-C syntax or memory management best practices. Swift. Major Swift version incompatibilities are the biggest issue. Libraries built with Swift 2.x, Xcode 7.2, are fundamentally incompatible with Swift 3.x, 4.x, and 5.x. Example project structure, static library in Objective-C. Here's a simple example of creating a static library using Objective-C in Xcode 7.2. 1. Create a new project ***. File-new-project. Choose iOS-framework and library ***Cocoa Touch static library. Name your library, example mystaticlib. Choose Objective-C as the language. 2. Add source files ***. Create a new Objective-C class, myclass.h and myclass.m. 3. Make headers public ***. Crucially, you must make the header files that you want to expose to your library's users public. Asterisk in the Xcode project navigator, navigate to mystaticlib-products-lib mystaticlib.a. Asterisk expand the lib-mystaticlib.a entry. Asterisk you'll see your header files. By default, they are likely set to project. Change the target membership of myclass.h to public. This exposes the header file to any project that includes the static library. 4. Build the library asterisk. Asterisk build your library, product-build. The lib-mystaticlib.a file will be created in the products folder. 5. Using the library in another project asterisk. Asterisk create a new iOS or macOS project in Xcode. Asterisk drag and drop the lib-mystaticlib.a file and the public header files, example myclass.h, into your new project. Asterisk important asterisk when Xcode prompts you, make sure copy items if needed is checked so that the library and headers are copied into your project's directory. Asterisk add library to linker asterisk in your target's build settings, go to the Build Phases tab. Under Link Binary with Libraries, click the plus button and add lib-mystaticlib.a. Asterisk import the header asterisk in your code, import the header file. Asterisk build and run your project. You should see the message printed to the console. 6. Conclusion and recommendations. Building libraries with Xcode 7.2 is generally not recommended if you plan to target modern iOS or macOS devices or to distribute your library for use in other projects. The Swift version incompatibility, potential ABI issues, and limited SDK support are major obstacles. Best practices asterisk. 1. Upgrade Xcode asterisk. The most important recommendation is to upgrade to a recent version of Xcode. This provides you with the latest Swift compiler, SDKs, and build system improvements. Xcode 13 or later is highly recommended. 2. Objective-C for compatibility asterisk. If you must use Xcode 7.2 for some reason, and backward compatibility is paramount, consider building your library in Objective-C. 3. Conditional compilation and weak linking asterisk. Use available checks and weak linking to handle API availability on older devices gracefully. 4. Thorough testing asterisk. Test your library extensively on a variety of devices and OS versions to identify and fix compatibility issues. 5. Documentation asterisk. Provide clear documentation for your library, including its target OS versions and any known limitations. While this tutorial covers the primary issues, keep in mind that software development is constantly evolving. Always stay informed about the latest best practices and potential problems associated with older development tools. A modern development environment is almost always the best path for stable and sustainable library development.